Okay, so let's get started. So first, some organizational things. The homework from last week was graded and returned, so you should find your homework. Okay, so it should just be sitting there in some folder that has the obvious folder name that you should expect. The homework for this week is now available, so you should find it in your project, and it's due on Friday at 6 as last time. Let's see, office hours. So my office hours, as I've mentioned, are normally for a half hour after this class. Today, I will leave immediately after class because I am teaching another class, substituting for somebody else right after this class. But the TA will have an additional office hour or office hours to be discussed now, which will happen on either Tuesday or Thursday. So do you want to say something? About how you want to determine that?
2:30 on Tuesday or Thursday.
Okay.
How does that not work for everyone?
He said 2:30 on Tuesday or Thursday.
Is it the time or the day? Can you usually make it? Can either of you usually make it to Wednesday or Friday after class? No. Okay, I'll talk to you later.
Okay, so Thursday or Tuesday?
Tuesday.
Okay, so tomorrow at 2:30. Okay, send out an email to the class saying where. Okay. Already mentioned that. Let's see, stickers. So there's a Sage sticker. You can take one and pass it down. I think there's probably enough for everybody. So just take one and pass it on. Okay, remind me to turn on the screencast. Actually, I didn't forget it. Should be recording right now. Let's see. Okay, so what we're going to talk about this week is Python. And in particular, we'll talk about how to make functions and to use various control structures like if, while, for, list comprehensions, etc. We'll talk about some of the basic Python data structures, such as lists, tuples, dictionaries, sets, etc. And depending on time, we may or may not talk this week about classes, methods of classes, inheritance, etc. So we'll see how far we get. I've made a project, by the way, that every single person here should be a collaborator on, and I want to show you that. So notice that it's called Shared Project, and then math480 and some other things. So this is in addition to your normal project where you find your homework. It's a free-for-all project. Anybody here can write or read anything from it. And I made a chat room that's there, which you can see here. And you can see that people are popping in. So if I type something or you type something, then it should appear in this chat room. Cool, +7. I had no idea what would happen with more than 3 or 4. There's also a worksheet. So if you click on the log, you'll see things that were opened and are being opened. And you can open that worksheet. So I don't know what will happen if more than like 5 people open a worksheet at once. I don't know if I've ever tested that. But an idea I had was that when we do exercises later on, so there'll be some things like write a Python function that does blah, like some really simple thing. What you'll do is paste your answer, like right here. See, it says exercise right now. So what you'll do is you'll put your name and then just paste your answer. And then we'll have like 40 answers pasted there that everyone can see. So that could be a fun way of seeing what happens. You can see that the little faces are on top of each, on top of some other things. I need to fix that. Cool. By the way, you can do emoticons with using this old ASCII art stuff. So if you go like that, you'll see a bunch of emoticons. Okay, so, and then also you can put stuff here. Okay, so first let's start. So first we're going to talk about functions, and then in a minute we'll do an exercise, and then you'll paste in your solution to the worksheet. We'll try that. So first, here's an example of a Python function. The syntax in Python is the following. You type DEF for def, like definition, and then you give a space, and then you give a valid identifier, which has to start with a letter, either lower or uppercase, or certain punctuation. You can start with an underscore. You cannot start with a number, though. Like you can't start with 0 as the beginning. And you can't start with $sign. In some languages, the $sign symbol can be part of a function or variable name, but not in Python. Also, one other key thing that causes a lot of trouble so Python, this language that Sage uses, there's something called Python 2 and Python 3. And Python 3 is kind of like the new modern version of Python. Sage still uses Python 2. And one of the differences that already comes up in naming functions or variables is that in Python 3 you can use Unicode in the identifiers. So you can define a variable and the actual name can be like have Russian letters in it or Chinese letters or whatever. Whereas in Python 2 you have to use standard ASCII. So name a function is just some boring ASCII. It can't be like some exciting crude characters or anything. But in Python 3, which maybe we'll switch to in a year or something, you can use much more exciting letters inside of function names. Okay, so the first line of the function, in this case, you say def, name of the function. You can put anything here that subject to the conditions I just described. And then in parentheses, you put the inputs to the function. There's no, there are no type declarations. There is some support in Python 3 for optional type declarations, but they're optional. In Python 2, you don't even have that. So you just give the name of a variable and then another name of a variable, etc. You can give 20 different variables, whatever number of variables you want here. There's also support for default input values for arbitrary number of variables and for other stuff, and I will get to that later, but I don't want to bury you in details. Okay? This is all you need to know to define a function. It's just def, name of the function, and then in parentheses the inputs, separated by commas. No type declarations at all, just variables. And then at the end you put a colon. You have to put that colon there. And then the entire body of the function you just indent. There's no curly braces or anything like you have in almost every other language. And there's no like begin, end words or anything like that. You just have to indent the entire body. In other programming languages, you always indent the entire body, but then you also put braces around them. In Python, that's just omitted. Just indent. To make indenting easier, if you highlight, so this is the case of pretty much any editor where you'd edit Python code. If you highlight a block of text and hit the tab key, it'll indent the entire block. And if you hit Shift Tab, it will unindent that block. This is really handy because otherwise you get really frustrated trying to do each one little by little. Like if you decided to put if at the top or to change something, it's really useful to be able to just indent and indent the entire thing. Again, that's highlight the entire thing and hit Tab or Shift Tab. Okay, so comments in Python are with the hash symbol. So you just put a hash and then the rest of the line is a comment. I think that Python doesn't have any multi-line comments like in many other languages, like /* and then you put a whole bunch of stuff, */ You don't have that in Python, it just isn't there. So if you have a whole bunch of text that you need to comment out, there is a way to do that in Python, but it's not some sort of multi-line comment. You can do, so there's one thing you can do is you can put, you can make like a triple quotes. That makes a multi-line string. And then you could just surround the entire thing in triple quotes. So that's one option. Of course, that just messed up my function, but that lets you have like a big block of text that's commented out. Another thing you can do, you can hold down, at least in Sage Math Cloud, you can hold down the Alt key and drag the cursor. I'm I don't know if that'll work in Windows, but on a Mac you can hold down Alt and drag the cursor, and then you get multiple cursors, and then you can hit the hash symbol, and the whole column will change at once. See, I have a whole bunch of cursors simultaneously. So that's another way of commenting out a bunch of code.
So what were the keys?
So on a Mac, it's exactly like Sublime Text. So you hold down some key, and then you can drag the cursor. I'm not really sure if this works on a PC, though.
It does, yeah.
Okay, awesome. It doesn't work on a Chromebook. I have a Chromebook where I have to click each time. I don't know how to drag, because Alt clicking is like right clicking on my Chromebook. Okay, so it works on a PC and a Mac. That's good.
Sorry, so hold Alt.
Yep, and then drag your cursor. So like, you can like paint a little region. You get multiple cursors. Is it working for you?
And then press.
Yeah, and then press anything, and it'll do something at every single point with the cursor. Okay, so those are ways of commenting out some code. Also, so this is Python code. Well, really we're working in a Sage worksheet. You can also put code in a .py file. You can write code directly in a terminal. You can use Jupyter notebooks. There's a lot of different situations in which you can write Python code. And this week we're going to focus on just the core ideas behind using Python. So like if statements, defining functions, and so on, and avoid getting confused and overwhelmed by writing code in files and running it that way and all the other stuff like that, okay? We will get into that sort of thing later, but that's not going to be our focus this week. All right, so once I've written my function, I can evaluate it. Why did it print out a bunch of stuff? Oh, it printed out this string up here. I'm going to just delete that since we don't need it. So in the Sage worksheet, you hit Shift-Enter and it evaluates it. Code that hasn't been evaluated yet, ever, there's just like a gray line all the way across, but if it's been evaluated during this session, there's a little blue line that indicates it's been evaluated during this session. The second you change it though, like I change this, notice the blue goes away because that particular code was no longer evaluated. Okay, here's how you call the function that we just defined. So you just give the function and then you give some inputs. And there we go. And then you can, it defined so the output, you say return and then something, and then it will return that. And that's what we got here. Every Python function returns something. If you don't explicitly return something, it returns none, which is something. So none is a predefined thing in Python, just like true and false are predefined in Python. So see true prints true and it's true. False prints as false and it's false. But none prints, well, it doesn't print anything else out at all, but it's kind of a funny special value. Oh, this is going crazy. It just disconnected for a second. Okay. I'm having technical difficulties. Okay. Right, there's the output. So none prints as nothing at all, it's just like empty. None is some special value in Python. And when you define a function and don't return anything, it still returns something, namely none. So that's just worth knowing. Okay, so I think since I restarted this, when I try to run this line, it's going to give an error. So this is the error you get if you try to run a function or you try to call something and it hasn't been defined. And that happened because I panicked for a moment, clicked restart at the top, and then restarted the entire process. So I'm going to go back up here, evaluate this code, so it's now defined, and then go down here and run it again, and now it will work. And what it does is what it says, the first argument is math and the second is 480. I'm going to split the screen for a moment so we can look at the code at the same time as looking at the output. And it's taking, I guess that's good. Okay, so here's, on the right you have the code, and on the left you have the output. So notice that it's probably better to split it the other way. Now that I see this. Okay, so what does the function actually do? So after the comment, it prints out the first argument is, and it just prints the first argument, second argument is that, and it returns the sum of the two arguments. This is another annoying point, but in Python there's a print statement. In Python 2 at least. In Python 3 there's no print statement, it's a function, so you have to put parentheses around the outside in Python 3, whereas in Python 2 you don't. So there's that. But in any case, you run it and it prints out what's listed there, and it returns the sum of the string math and the string 480. Or in this case, the string 15, well, the string 15, the number 15, and the number 19 get 34. So you can see that plus has different meaning depending on the type of things that you're adding together in Python. Okay. Just going to move that down. Skip that. Okay, so let's do the first exercise. So what you're going to do is define a function that computes the average of 4 numbers. It should, and returns it. So it should be pretty easy. It should be 1 line long. Yes?
Do you want us to do this in the shared project or our own project?
Do it in your own project, and then when you're done, copy your incredibly complicated 1 line long function from your project to the shared project and put your name next to it. Okay? That'll give me a sense of who's done. So you do it in your own worksheet and then copy it. And I'm going to open up the other worksheet so you can see what happens. So as you can see, so far nobody's pasted any code here yet. So again, you want to write the code in your own project so you can easily test it out and then just paste it in here once you've written it, okay? Don't try to run it here. That's going to be a disaster. So this is, if you haven't written Python code before, this will be the first function you ever write. And you can kind of see what some people are doing. Looks like everyone's writing pretty much the same thing. So total chaos is reigning. That one looks pretty good right there. And try it out. Once you've written the function, actually try running it on some input to see what it does. Okay? Try putting some numbers in. And if you have any questions, let me know.
I made a bunch of cells.
You can help. Alright, let's see. I think you need to evaluate the cell. Yep. Yeah, that's how they get cell. Yep, there it is. Yes. Yes. Okay. Yeah. So Sage worksheets are not anything like Microsoft Excel in that you have to evaluate the function that you define before you use it. Okay? It doesn't just sort of like, and if you change the function, you still have to evaluate it again. Otherwise, it's just kind of sitting in the editor. Any questions? You didn't you change it to, yeah, if you change all the prints to return, then it'll, so it's how it's printing the opposite of function. And functions in Python always return. So you can have return quotes. So that's not going to be good. You probably want to put whoever that doesn't return stuff. And it just finishes. It takes a little while the very first time. Yep, now try and then now just try typing up the functions and see what outputs. So like just type output and show the
Oh, the Jackson.
Yep. Ooh, works. Any questions? Yep. Yes. Yep. Right, but the reason is just that it's not defined. So if you evaluate this, evaluate that cell. So hit, just and hit Shift Enter or click Run. And now evaluate the next thing. Cursor. Yep. Yes, you always have to run the code first before you can use it. Yep. Any questions? Yes. No, you could just do return without that. You can do that too, but you don't have to. Any questions? Sure. Put it anywhere you want. You can if you want. Sure. Go for it. It's up to you. Any questions? So here you just need to return and then the output right after the return statement. But you don't want the return statement. I only want to use that whole line. And now we can try running it. There's a syntax error. You have to put a colon right at the end of the line where you find the function. So where it says def, like the function definition has to right after num4 is the colon. Very end. Sorry, right after the close parentheses after num4. So like here, you have a colon. And then now you run it, and now you can call the function something else. So if you put your mouse over the blue line right there, like and now just do ADG and give it 40 signs or whatever. You got it? Any questions? Good. You can't do return by itself. You can only use return inside of a function. And up here, you're inside of a function. Down here, it's just like up there. This is good.
Yeah, there's a lot of functions.
So I'll just delete the line that has return. And I just wrote that was an object. You should get 5 comes out. Yeah, so you get this from that. Oh, and then try changing. Figure it out. Great. All right, any more questions? All right, let's move on. Okay, so the one thing you've learned to do so far is to write a function. And now the next thing we're going to do is talk about if statements, while loops, for loops, etc. These let you actually do really interesting things inside of your functions. Okay? So first there's the if statement. And you'll notice there's a pattern with a lot of these Python constructions. Just like with defining a function where you say some little short abbreviated word, then something, and then a colon, you have exactly the same thing with the if statement. You use the word if, then some stuff there, like a condition, like if 3 equals 5 minus 2, there'll be some condition, and then a colon, and then everything that you should do if that's true gets indented. Else, you can do else or elif. You can ignore that for a little while. You can just stop here with if something and then some code. The code will get run if the condition is true, otherwise not. But with an if statement, you can also do elif, and then some condition, and then a colon, and then everything that's indented below it, that gets run. And you can have a whole bunch of elifs. And then finally, you can have an else, and then some code, all indented again, that gets run if none of the other conditions are satisfied. Pretty much all the Python things look that way. You have a little keyword, some code or expression or something, and then a colon, and then a bunch of stuff that's indented. So you'll see that repeatedly. And then the condition, you can use double equals for two things being equal, bang equals for not equals, and you can also use words and, or, not, and so on. You don't have the ampersand type thing that you might have in other languages. It's just the word and written out, and not, and so on. Okay, so now let's look at a function that uses an if-else construction. Oops. So I just made a little function called parity, and it's a function. It takes one input, n, and what it does is it says if n mod 2, so what that does is it divides n by 2 and takes the remainder. If that's 0, print the word even. If it's 2017, I wanted an elif. So elif it's 2017, print odd, that is next year. Else, if neither of these conditions is satisfied, it prints out odd. Okay? And so whenever you call parity with some number, this will work. Notice, by the way, though, this function is just kind of implicitly assuming that the n that you give it is an integer. But you could call parity with absolutely any object at all in Python, and it might do something meaningful, or it might just blow up in some surprising way. And that's how Python works. So watch out for that. So that can often make it easy to write code, but it can also bite you later. In any case, let's try this out. So if you give 3 as input, it says odd, because neither of the first two conditions is satisfied. If you give 6 as input, it says even, because that is the first branch. And if you give 2017, it says the string right there. Okay? And you could put a lot more code. It doesn't have to be just one line. You could put like 10 lines of code where it says print even. The key thing, though, is that all that code needs to be indented in a consistent way. And you can indent even more. Like, you could define a function inside of here if you wanted. And we'll also learn about for and while loops in a moment. You could define a for or while loop inside of here. Okay, so that's any questions about the if statement? It's pretty straightforward. If, condition, colon. That's all there is. And then the other thing to remember is that it's elif. This 4-letter funny-looking thing, elif. You might think it would be else if, but it isn't. It's elif. So there you are. In some languages, it would be else if. Also, one other point, there's no switch or case statement in Python, like you might have in C or Java or JavaScript. So if you have a whole bunch of conditions and you want to do something if one of them is satisfied, you have to use if, elif, 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 elif. Or you can use a Python dictionary to control the logic as well and have the values be functions. But you can't use a switch or a case type statement. Okay, exercise. Write a function that takes as input a number, so just like above, and then it prints negative, positive, or 0, depending on whether the number is negative, positive, or 0. Okay? So this should be an easy modification of the code that I just showed you above. And then, let's see. So start pasting in your answers in here once you figure it out. Looks like one person did it already. But they did theirs incorrectly according to the directions. Whoever did my sign RL. Because stupidly, my directions say to print out the number, not to return it. Or to print out positive, negative, or 0, not return it. Not saying that I wish I had actually made it this way, but that's not what I did. Okay, so give it a shot. And it should be just an easy case of modifying this thing up here. It looks like somebody slightly changed it. Okay, so try it out. See if you can make something that does the appropriate thing. 0, positive, or negative. Okay? So if you have any questions at all, just raise your hand. Yes. So what I like to do is put your cursor here and value it once. Yep. Yeah, this is shift enter. Oh, no. Just put your cursor anywhere up here, like anywhere in the cell, and then just hit shift enter. Right. And now it's evaluated, so you get the line. Now you can yeah, exactly. Yep. And then, like, once you do that, the Python process that's running is the definition of the function. So it doesn't worry about the definition. It's just like since the function. Any questions? You got it. Any questions? Any questions? Questions? All right, let's move on. Any questions in general? Looks like people are figuring this out pretty easily. Let's see if somebody pasted in something that's good. Okay. Yeah, these look great. Okay, awesome. Look at all these. Okay, moving on. All right, so next after if, we have for loops. So here's, okay, so to do a lot, here's the first thing you need to learn. So there's this funny function called range in Python. And what it does is it takes as input an integer, in this case 5, and it gives you back a list of the integers from 0 up to the input number minus 1. So it gives you back a list. If you give it 5 as input, it gives you back 5 numbers. The numbers 0 up through 4. So it's a little funny, but that's the way it is in Python. So this is a useful thing to know about because the way for loops work in Python, you say for variable name in, and then you give something that can be iterated over. For example, a list. And then it sets that variable, in this case I, equal to each in order of the values in the list. And then you can run code inside of it with the variable equal to those values. Okay? So if I change this to 10, what's the output going to be? 0 through 9. It's not going to have a 10. Yep. And now if I do this, if I change it to a 10, it's going to say hello. How many times is it going to say hello? 10. But the last time it says hello 9. Okay. By the way, what do you think I is equal to now? The possibilities are it's not defined at all, it's equal to 9, or it's equal to 10. Those are the only reasonable possibilities. So which do you think it is? Turns out it's 9. It's equal to the last value it took on in this list. It can't be 10 because the list doesn't even have 10 in it. Who's to say that the quote next element would be 10? So it's not like a for loop in C or something. So it definitely shouldn't be 10. The only kind of weird thing here is the fact that I is defined at all after this loop. And that's definitely a potentially troublesome and disturbing way in which the for loops work in Python. But that's the way it is, so understand it. So after a for loop, the variable is equal to the last value that it had inside of the loop. Okay, so that's a for loop. It's pretty simple. Let's do something with it. So we're going to finally write a program that actually does something slightly interesting. This little function, sum up to n, it sets s equal to 0, and then it does a for loop where I is equal to 0, 1, 2, etc., all the way up to equal to n. Of course, I equal to 0 is kind of silly. And then it adds to s the value I, and then at the end it returns s. Okay? So if you evaluate it and then you do, maybe I'll do a really simple one, sum up to 3, that should give us 1 plus 2 plus 3, or 6. And then there are some other values here as well. Okay, so that's for loops. You do for blah in something. And the interesting thing is you don't have to just give range. There are lots of other ways of making something that can go right here. And there's also various inputs to range. For example, and you can look at, so if you do range, say 7, 50, stepping by 3, what it does is it does a range starting at 7, ending at most 49, and it steps by 3 each time. So there's a lot of ways of constructing these things that you iterate over. If you want to figure out what this range does, you can do, if you put your cursor right inside, as if you're about to sort of write some inputs, and then hit the tab key, it will pop up some help telling you how that function works. You can do this with any function. You can also type range question mark, like all by itself, and then hit shift enter, and it will print the output there. Yes?
Is this a Sage thing?
Yes. This particular thing is a Sage thing, which we surely copied from some other IDE. Wait, when you say Sage thing, do you mean getting the help or range? Yeah, the help in that way is, although the range function itself is just built into Python. And at least using question mark, that's extremely common in like IPython and other Python environments. In Sage, we do have some enhanced range-like constructions. For example, you can do square brackets 5 ... 15 close square brackets. This is Sage specific, and what it will do is give you the numbers from 5 up to 15. And you can even do things like, I like 5 and then 5.7 ... 15, and it will figure out what it needs to put in to give you all the numbers from the starting point to almost the end point, adding this amount each time. So that can be useful for iterating and so on. Yes?
Is it better form to put the plus one when you're doing sum in your range or in your I? So it's better to say n plus one or I plus one?
In this particular case, it probably would have been better to put well, the best thing here would have been to put range 1 comma n plus 1, I think. Yeah. So yeah, I think n plus 1 in this particular case is fine. Okay, so here's what you're going to do. Sum the kth powers of the numbers up to n. Should be like almost exactly the previous function. The only difference is that you have to replace the number, like right where it adds a number, I, you just put the kth power. And in Sage at least, to compute, so 4 to the power of 5, you just put 4 caret 5. Since we're talking about Python, I should point out that in Python, you have to put 4 double asterisk 5 to get exponentiation. Sage just changes this to this, so you can put either one. It is a subtle point though, in Python, if you put 4 caret 5, it computes the exclusive OR of the numbers 4 and 5. So it like takes the binary strings and then exclusive ORs them. So that can be very confusing. And just to point that out, if I do %Python, then it's just as if it were in pure Python. So 4 caret 5 is 1. In any case, don't worry about that too much today. So write a function that sums the powers up to n. This should be like just copy paste and then put something to put an exponent. You should be able to do it in like 3 minutes. Okay? And then try it out on some input. Like, what are the sums of the squares up to 100? What is that? Let's see. That would be cool. Lots of people have done it. All right. If you have any questions, let us know. Try the, I was just talking about. Did you assign something to matrix or this question? I think you assigned something to matrix. If you do reset and then it puts matrix, then I'll reset it to have this when the session started. Quick reset. But matrix is like a really complicated function, and now it's been turned into this. Yep. You just watch a whole bunch, and this will be lots of examples of how to make matrices. Pages. Yes. Yes. Any questions? So we look to make sure you have the colon. Both of those are super important. Python cares a huge amount about colon and indentation. Lots of languages. Any questions? Sorry. Questions?
What was the same?
Yes. And then get rid of the plus.
So you do that to
Yeah, okay, now try it.
and then when you do that, the two numbers, there's another 6. So you have to switch to, multiplications of 4 and 5, and then sort pretty.
Oh, these the two numbers are the inputs to the functions when you define the function have to be numbers. Make them numbers. Yeah. So if you look at the other example, see how the input is n.
You should have never did it unless you do
So you have to give a variable. Yes. Yeah. They only get defined when you actually call the function. So basically, like change the 5 to n, just n down there. It's good. Any questions? Any other questions up here? Right. All right, so you can see many correct answers. And the sum of the squares up to 100 is apparently, this code's right, 338,350. All right. Okay, the next thing is while loops. So you could say, while something's true, colon, and then you give a bunch of code. This should feel really familiar. It's just like with if and def and everything else. It's just some word, keyword, and then some condition, then some like expression or something, colon, and then indent, and then you do something. And what happens is this, it'll evaluate this condition to see whether it's true. If it is true, then it runs the code in the block once, and then it evaluates the condition. And if it's true, it runs the code in the block ad infinitum until at some point, hopefully, the condition's false. And then it doesn't run the code in the block, and it moves on to the next thing. So that's what a while loop does. And there's one other thing. If in the code you have the word break at the same level as the while loop, it'll break out rather than running the condition again, rather than evaluating the condition again. So here's an example. I said I equal to 5, and then as long as I is greater than 0, it prints I, and then reduces I by 1. It just keeps doing that. So the first time through, I is 5, and then it reduces I by 1, so now I is 4, I is 3, I is 2, I is 1, and then right after it prints I is 1, changes I to be 0, then the while loop isn't, the condition here isn't true anymore, and so it breaks out. And then it just goes, it's done. So there you are. So here's an example of a function that prints out all the prime factors of an integer, and it uses a while loop. So it's a slightly more complicated function. It's called myFactor. It takes an integer n, or whatever you give it as input, but it probably won't work if n isn't an integer. And then as long as that number isn't prime, it finds a divisor using trial division, which in reality, this could actually fail if the number is very large. Trial division only searches for a while and then gives up, in which case this would loop forever. But it tries to find a factor via trial division. These two functions, isPrime and .trial division, these are not included with Python. They're special functions that are part of Sage that a lot of work went into, huge amount of work went into. So what it does is it finds the smallest prime factor of n using trial division, divides it out from n, says that it found the factor, and then it keeps looping. And as long as the number is not prime, it keeps trying to do that. And then when eventually n is prime, it says it's finished. Okay? So we'll start next time with list comprehensions. We're going to talk about lists, sets, dictionaries, and other Python data structures next time.
What's in this stuff?